All right. So we're first going to go over piecewise defined functions. So these are functions that are defined on different pieces of the domain. So first thing, what we want to do is review some of just the key graphs and functions that we're going to look at here. So some common ones. So up here in the top left-hand corner, we have a quadratic, or just x to the second power. Right next to that, we have x to the third. And similar to those, we have the corresponding inverses of both of those. The inverse of the x squared is the square root of x. And then the inverse of x cubed is the cubed root of x. And then the other two common ones we have are 1 over x and then the absolute value of x. So these are the 6 common graphs we will look at. But let's see, how do we actually use these piecewise defined functions? So this is on the first page, the second page. So it says when a function is defined by more than one equation, it is called a piecewise function. So here in this case, we have 3 pieces: when x is less than 0, when x equals 0, and when x is greater than 0. So what we're going to do is just see which piece does each of these values fit in. So if I'm looking at finding f of minus 2, minus 2 fits into this piece here up top, right? When x is less than 0. So that's what I'm going to plug it into. I'm going to plug it into this function that's defined on this piece. So if I do that, I'm taking minus 2, and I'm cubing it. And if I do that, it's minus 8. That's simple enough, right? I see. Where does this value of x, what piece does it fit into? And then I plug it into the function that is defined on that piece. So let's do the next one. It says, what is f of 0? So what piece does 0 fit into? When x is 0, I'm looking at this middle piece here, right? This is when x is 0. Now, when x is 0, the function is defined as just minus 10, so it's a constant function on that interval. So then f of 0 is minus 10. And then the last one on here we have is f of 4. So when is x equal to 4? Which piece does that fit into? This one right here, right? X greater than 0. So I plug in 4 right here into this one. So if I do that, f of 4 is equal to the square root of 2 times 4 plus 1 under the square root. So that's 8 plus 1, or it's the square root of 9. And that's just 3. So all we're doing here is seeing what piece does this given value of x fit into, and then plug it into that function. So it's not too difficult. You just have to know which piece you're plugging into. So that's the first example there. This next example here has a typo in it, and I can't actually fix it because whenever I was given the notes, they were imported as a PDF, so I couldn't edit the PDF. So I'm going to read the question first, and then I'll show where the mistake is. So it says a telephone company offers a monthly cellular phone plan for $29.99. It includes 250 anytime minutes plus 30 cents per minute for additional minutes. The following function is used to compute the monthly cost for a subscriber where X is the number of minutes used. So the mistake is in the bottom piece. So it should not say 0.3x minus 45.01. It should say minus 45.01. $45.01. 0.01. That's just what it says. So with that fixed, then the rest is just the same as the first part. So if I want to find what is the cost for using 200 minutes, so this would be C of 200. If I want to find that, what do you think it is? Someone type it out or just say it out, either one. What do you think C of 200 is? Yeah, $29.99, right? Why is that? Because it fits in the top piece here, right? 200 is in between 0 and 250. So therefore, its cost on that piece is defined by 29.99. It's just a constant function on that piece. The next one, I want to find the cost for 250 minutes. So this is C of 250. Can someone tell me what the cost is on that one? Yeah, again, it's $29.99 because this inequality sign here has equal to on it. So this is for anything less than or equal to 250 minutes. So therefore, it's going to be, again, $29.99. So those two fit into the first piece of the domain. The next one fits into the second. So here it says for 370 minutes, find the monthly cost. So all I'm going to do is plug in 370 right here into this bottom one, right? So if I do that, C of 370 it ends up being 0.3 times 370 minus 45.01. And when I do that, someone tell me what I get. Yeah, 65.99 is correct. So these aren't too difficult, right? At least when we're plugging into these piecewise defined functions, all we do is see what piece do I actually need to plug it into, and then plug it into the function that's defined on that piece. So now the graphing part is a little bit different. So we have a couple of different things that can happen. Either the function is continuous and they match at the point of discontinuity, so the values of y match at that point, or they could not. So let's see what happens. So the first step is we first look at what happens at the point of where the domain is split. So here, that point is when x is 1, right? Because here, that's when we're breaking it up. So what we do is we first plug in x is 1 to both pieces. So if I plug it into the top, so this would be minus 2 times 1 plus 1. So if I plug it in the top piece, I get minus 1. And if I plug it into the bottom piece, that's 1 minus 2 or minus 1. So in this case, I actually get that at the point of separation between the two pieces of the domain, the y values match. So that means this function is actually continuous. So now it says evaluate this to the left and the right of x is 1. So what we're going to do is say find f of 0 and f of 2. because that will give me a piece that fits into the top one whenever I plug in 0, and to the bottom piece whenever I plug in 2. So let's do that real quick. So f of 0 is what? When I plug in 0, I get what? Yeah, 1, right? It fits into the top piece. -2 times 0 is 0. 0 plus 1 is 1. So now I want to find what's f of 2. So f of 2 in this case, if I look at that, it fits into the bottom piece, right? So f of 2 is what? 0. Yeah. So now I can actually graph this. So if I want to graph it, I'm going to draw an axis here. So let's go a couple out. 1, 2, 3, 4, 5. 1, 2, 4, 5. And then 1, 2. Okay. So what we're first gonna do is plot the point of 1, 1, right? Or 1 minus 1, not 1, 1. Because whenever we plugged in x as 1 to both these pieces, we got -1. So the first piece we're going to have is at 1 minus 1, or the first point, I mean, right here. And now what we're going to do is look what happens to the left and the right. So remember, to the left, remember we plugged in x as 0 and we got 1. So if I do that, here is a point on the left-hand side, and I can create the line by just connecting these two dots and continuing it on, right? So that's what it looks like on the left-hand side. And on the right-hand side, remember I plugged in x is 2 and I got 0. So here we have 0.20. And I can connect these two with the line, and then it goes on forever. Again. So that's what it looks like whenever we graph it. Is everyone okay with that? It's a little different. But first, you just look at the point where the domain breaks up. Plug in that value to both pieces. Then, if that value on each of those pieces, when you plug in that value of x, if it's the same value of y, then it's not going to have a jump or a hole or anything like that. It's just going to be continuous like this one was here. So now it asked you to find the domain and the range. The domain, remember, is the possible values of x you could plug in. The range is the possible values of y you could get out. So in this case, what's the domain? Anyone have an idea? If we're doing it in interval notation, it's what? So what can I plug in for x? It's going forever in the left direction, and it's also going forever in the right direction. So I can plug in all real numbers, or particularly the domain is minus infinity to infinity. Now the range is more restricted because what's the smallest value of y we have? So the smallest value of y isn't 0, but it's close. Not 1, but -1. There we go. -1 is the smallest value of y. And then what's the largest value of y? It continues on forever up, so it's infinity, right? So the range is from -1, including -1, to infinity. So now it looks for what are the intercepts? So where does it cross? So I'm going to actually label these. So it crosses right here, and right here, right? So it's talking about X and Y intercepts in this case. So I already know two of them, right? We know this point here, and we know this point here. So the first one is the point 0, 1. The second is the point 2, 0, right? So all we have to do is find the third point. So all that is here, this is the left piece, right? So it's looking at this function here. And it's saying, when is that function equal to 0? So if I evaluate that, so -2x plus 1 equals 0, and I solve this, I get x is what? Subtract the 1 over, divide by the -1. Yeah, you get a half, right? So the other intercept is 1/2, 0. So now the last question on here is f continuous on its domain. What do you think? Yes or no? Yes, it is. There was a smooth transition here because at the point when x is equal to 1, we had the same value of y. There wasn't a jump. So therefore, yes, it is continuous on its domain. So that one is a simple example where we look at two pieces. Now let's look at a more complicated example when we look at three pieces. So it says evaluate the first piece at x is -2 and x is 3. And there will be an open circle at x equals 3. So what it does is it evaluates it at these endpoints, right? Here's the lower endpoint, -2. Here's the upper endpoint of 3. And it says there will be an open circle at x equals 3 because this inequality right here is strictly less than 3. Not less than or equal to 3, but less than 3. That's why there's an open circle. So if we evaluate the first piece at x is -2, so -2 plus 1 is -1. So this corresponds to the point -2 minus 1. And then we evaluate this piece at 3. So if I do 3, it's 3 plus 1, or 4. So this corresponds to the point 3, 4, right? So now I know these 2 points. So let's actually draw the graph now. Let's start it. That way we can go step by step as we go. Okay. So first we want to plot these 2 points, -2, -1. So that's right here, -2, -1. So it's this point right here. And the other point was 3, 4. 1, 2, 3, 1, 2, 3, 4. So here, remember it says, it needs to go more to the left. Remember it said we're going to have an open circle because of that inequality sign, because it was strictly less than. So we can't include it, that endpoint, so we can't fill in that circle. So then I just create a line with these 2. So that's the first piece. That's what it looks like on the first piece. Now the second point says plot, or second part says plot the point -3, 3. This will be the second piece right here, because when x is 3, the function on that piece is f of x is -3, or y is -3. So we plot the point 3, and then -3, 1, 2, -3. And here it has a closed circle because we have equality at that point. And now it says evaluate the third piece at x equals 3 and to the right of it. So if I do that, when x is 3 and I plug that into the bottom, this would be -2 times 3, or -6. So this corresponds to the point 3 minus 6. And then if I want to find another point that's on this, let's say, for instance, evaluate this at 4. If I evaluate this at x is 4, so -2 times 4, and this ends up being -8. So another point I can use to actually graph the function is the point 4 minus 8. So I go 3 minus 6, which is right here. Let's try to make that a better open circle. And then the next one was 4 minus 8, which is roughly down here. All right, here. These. And in this case, is the domain restricted? No. So it says for anything greater than 3. So this piece is going to continue on forever in this direction. So that's what the graph looks like for that one. So that one's a little weirder. So now in this case, what's the domain? What's the smallest value of x I can plug in to that function, to that piecewise defined function? What's the smallest value of x that works? What do you think? If I'm going from left to right, what's the smallest value of x? If I look at the graph, it starts right here, right? This is the smallest value of x I can plug in. That's when x is -2. So the domain goes from -2 and if you look, I can plug in anything to the right of that, so it goes up to infinity. So the domain is from -2 to infinity. The range, I just write as a union of intervals. Because in this case, none of these pieces overlap. So how you can write it is just look at what's the range of the first piece, what's the range of the second, what's the range of the third. So if I'm looking at the first piece, the range of the first piece is from here. Let's do it in a different color. From here to here, right? So that's from -1 to 4, but not including 4, right? Because there's an open circle. So -1 to 4. With a parentheses around the 4, right? Because we can't include the 4 because there was a open circle. The range on this piece right here, the second one, is just a single point. It's the set containing the point 3. So we're going to union this interval with the set containing the point 3. And then to find the range of the last piece, the smallest value of y, it goes forever in the negative direction. So the smallest value of y is -infinity, right? And then what's the largest value of y? Right here, whenever we have -6. So this is -infinity to -6. With parentheses around both because you can't include either of those endpoints because you have an open circle here when you have -6, and then also you obviously can't include the point -infinity. Now, what we want to do is find the two intercepts. So in this case, my graph wasn't very good drawing. So let's see, where will these two intercepts happen? They're going to happen on this first piece right here, right? Because this is the only place where it'll cross the x and the y-axis. Dang it, sorry, I'm trying to erase a couple of these things. Okay, so here we had a closed circle, here we had an open circle. So if I would have drawn this better, then it would have made it easier to find the points, but let's just do this. So it's going to be on this first piece. If we want to know when y is 0, so if I want to know when y is 0, then x plus 1 would equal 0, or you get x is -1. So the first intercept is actually -1, 0. So that's the x-intercept. And the other intercept is going to be what happens whenever I plug in x is 0 into this to get the y value. So this first point was -1, 0. That's the x-intercept. Now for the y-intercept, what I want to do is actually just plug in x is 0 into this top piece here. If I do that, 0 plus 1, then I get 1, right? So that means my y-intercept is the point 0, 1. So now I know the two intercepts for this. I know the x-intercept and I know the y-intercept. Now it asks for what's the point of discontinuity? F is discontinuous at x is what value in this case? What do you think? Anyone have an idea? Where does the graph do a jump? At what x value? 3, right? We're looking at x is 3. right here, it jumps from here to here. And it also jumps from here to here. So that is where the discontinuity is, that x is 3. So let's look at the next one. So this one here, you actually have to find out what it is on that piece. So here, the easiest part is identifying the domain for each of these, or the possible values of x. So if I look at this one here, let's start with the left-hand side, this part here. So this left part here is just defined for x between what two values? What do you think? The smallest value of x there is -1. The largest value of x is -1 to what value? What do you think? It's from -1 to 0, right? Here. So we're just looking at the left piece, not the entire thing. So here, this first piece is just defined from x is -1 to x is 0, right? So that's where it's defined. Now we just need to figure out what this function is. So there's no y-intercept, so it's just going to be a slope in front of an x. So here we're going to have an x, and then the slope in front of it. So what's the slope? What is it? So if I count, it's down 1, and then over 1. So the slope is -1. So all it is on the left piece is -x. Simple as that. Did everyone see how I did that? Yeah, so that one's not too bad. The next piece isn't too difficult. So let's look at this next piece. So this next piece uses values of x that are from here to here, right? So that's from x is 0 to x is 2. And now, so again, this is just going to be where you have an x and then the slope in front of it because there's no y-intercept. In this case, the slope is, we go up 3, 1, 2, 3, over 2. So the slope is 3/2. So this is just f of x is 3/2 x. So does everyone see how we can identify the function, the piecewise defined function on each piece, if the functions are actually pretty simple? So in this case, they were both linear functions with no y-intercepts. So we just had to figure out what's the slope, and that was it. Everyone okay with how I did that second part, the right piece? Okay. Now, let's look at the class activity. This one here isn't too difficult. So first, it says, what is f of 0? So am I plugging in 0 to the top or the bottom? Top, right? So if I do f of 0, that is -3 times 0, 11. 11, right? The next piece, what is f of 2? The next part, what is f of 2? What do I plug into the top or the bottom? Top again, right? Because we have equality here. So this would be minus 3 times 2 plus 11. So that ends up being 5. So those two parts are pretty simple. Now it says, is f discontinuous at x is 2? So here, we already know what x is 2 on this piece, or what y is when we plug in x is 2 here. So whenever we plug in x is 2 to this piece, we get 5. What do I get when I plug in x is 2 to the bottom piece? What do I get? 5 again, right? So is f discontinuous at x is 2? What do you think? So whenever I plugged in x is 2 to both of these pieces, I got the same y value. So there's no jump. So is f discontinuous at x is 2? No, it's continuous. So that's how you identify it. You look at the point of where it could be possibly discontinuous. You plug in that x value to both of the functions. And if both of the values on those functions are the same, then it is continuous. Otherwise, it's discontinuous. Then what is f of 3? You plug it into the bottom piece and you get what? Someone tell me. 10 is correct, yeah. F of 3 is just 3 squared plus 1, so that's 9 plus 1. So that is the first section that we'll cover today. That's over piecewise defined functions. So the next section we look at is over different types of graphical transformations. So taking graphs, moving them up and down, the left and the right, and compressing or stretching them. So let's go ahead here. So it starts off by doing the same thing. It gives you these graphs, the key ones that we look at, the same ones as before. So we first talk about vertical and horizontal shifts. So moving stuff up and down and to the left and the right. So these ones aren't too bad. At least the vertical ones are easier than the horizontal. But let's look at this. So it says for vertical shifts, the graph of y equals f of x plus k is shifted up k units. So what it does is it takes the original function f of x and it adds a constant to it. It just shifts it up. Similarly, if we want to shift something down, then we don't add k, we subtract k. If we want to shift something down, we subtract k. So here, it gives an example where the original function f of x is x squared. And what it does is one of these graphs shifts it up, one of them shifts it down. So let's look at the blue one first. So the blue one, remember, what it did is it shifted it down 1 unit. So what it does is it just takes the original x squared function, and since we shifted it down 1 unit, it's just minus 1. X squared minus 1. That's all it did. It shifted it down 1 unit. So to do that, we take the original function of x squared and we subtract 1. That'll shift it down 1 unit. Can someone tell me what happened for the green one? The green one got shifted up how many units? Up 3 units, right? So whenever I write what is the green function, again, we start off with the x squared part. But in this case, it went up 3 units, so it's x squared plus 3. So these vertical shifts are a lot easier than the horizontal ones. The horizontal ones are a little different. So let's look at how we identify these horizontal ones. So are there any questions over the vertical shifts first? The vertical shifts are the easier ones. Okay, so moving on to horizontal shifts then. So it says the graph of y equals f of x minus 8 is shifted right h units, and the graph of y equals f of x plus h is shifted to the left h units. So it's weird because here we have a minus h. So you think it would actually be shifting it to the left, but indeed it's actually shifting it to the right. So whenever we have these, we want to see what, whenever we look at, oh, makes sense in a second what we're doing. But just think of it this way. Whenever you have a minus in front of the h, it's going to the right. Whenever you have a plus, it's going to the left. So here, this example, the red graph is the standard absolute value of x. So let's look at the blue one first. What would the equation of the blue be? So here, the blue one went to the right 1, 2, 3, 4 units, right? Went right 4 units. So that means we're going to have f of x minus 4. So let's see what this would look like. So f of x minus 4 would look like the absolute value of x minus 4, right? So the function on that piece is just y is x minus 4 in absolute value, right? So this would be y is the absolute value of x minus 4. Now, let's look at the other one. When we have this green one here, so what is this one? It went to the left 2 units. So this would say y is the absolute value of x. And in this case, it won't be minus 2, it'll be plus 2 because it went to the left. So these ones you just have to be careful. So what did it do when we looked at vertical shifts? It added a constant at the end of the function. So here it just added a minus 1 and a plus 3 to shift it up and down. What did it do when we went to horizontal shift? It didn't just add a constant outside the function, it did it inside the function, right? Because here, what it did is it did the x minus 4 inside of the absolute value. Not outside of it, but inside of it. So in this case, it actually goes inside this function. So here, it went inside where we usually plug in x, and instead it plugged in x minus h. And here again, whenever we usually plug in an x, it plugged in an x plus h. So the two differences between these is one, it just adds a constant on. It doesn't add it or do it inside the function. It does it outside the function, right? Here we just have regular f of x. Here we just have regular f of x. And then we have the constants outside the function. But here, on the other ones, we have them inside the function. f of x minus h and f of x plus h. Everyone see the slight distinction between those two? Between the vertical and horizontal shifts. Okay, so now let's look at reflection over the x-axis. So the graph of y equals negative f of x is reflected over the x-axis. So if you look at this example here, the standard graph in green is the graph of x, or the standard graph in red, my bad, is the graph of y equals x cubed. So what is the equation of the green graph? All it does is it throws a negative in front of it. So in this case, the green graph is just y equals negative x cubed. It just flipped it over the y x-axis. So y is negative x cubed. Let me draw that 3 better. That one's actually pretty simple, at least for this example it is. So those were 3 different types of shifts, or 2 different types of shifts and a reflection. So now let's talk about how do we stretch and compress a graph. So here it says the graph of y equals a times f of x is stretched vertically if a is greater than 1 in absolute value. So if I take the absolute value of a and it's greater than 1, then it'll be stretched vertically. So that means it's going to grow faster. But if I want to compress it vertically, then that value of a is between 0 and 1 in absolute value, and it grows slower. So here it gives an example of where the basic function is the square root of x. One of them is a stretch, one of them is a compression. So out of those 2 graphs, the blue or the green, which one is the stretch, green or blue? Yeah, the green is the stretch, right? The green is where it's growing faster. The blue is where it's growing slower. So let's look at the equations of each of these. So the blue one, so it says 1 is stretched by a factor of 3 and 1 is compressed by a factor of 3. So if it's compressed, which is the blue one, by a factor of 3, then we actually have that the function is y is 1/3 times the square root of x, right? So that's what happens when we want to compress it. We do 1 over that factor. In this case, it would be 1 over 3 because the factor is 3. The green one is faster, right? So it's not not multiplying it by 1/3, but multiplying it by 3. So the green one would just be 3 square root of x. Notice how both of these have a 3 in there. So this determines whether it's a stretch or a compression. If it's a compression, then it's 1/3 stretch multiplied by 3. Oops. Switch this real quick. Here. So those were all the different shifts, stretches, compressions, and reflections that we could do. So now let's look at this example here and go through all of these different types of shifts and identify them. So first, we're going to go with vertical shifts. So the vertical shift here is what? Is it down or up, and how many units? Yeah, down 2 units, right? So it's a vertical shift down 2 units because this minus 2 here, right? So vertical shift down 2 units. Now the next one was horizontal shifts, right? So let's say horizontal shift. So in this case, is it to the left or the right, and how many units? Left 7 is correct. Because inside the square root, we have x plus 7. So it actually went to the left 7 units. Now, what other shift did we have? We had reflection. So is it reflected across the x-axis? What do you think? Is there a negative out front of this? Yes, so it is reflected across the x-axis. So reflected over the x-axis. And is it stretched or compressed in this case? Yeah, it's compressed vertically by a factor of what? Not a fourth, but just 4. Whenever we say it's compressed, then automatically A is between 0 and 1. So when we say by a factor of 4, it's implied that it's actually just a fourth that's out in front of it. So that's all of the shifts, stretches, and compressions that were to this function here. Now this next one here, so suppose the graph of y is 1 over x is shifted right 2 units and up 4. Write the equation of the new graph, then sketch it. So this one's a little harder to sketch, but we can try. So y equals 1 over x is our basic function. It's shifted to the right 2 units and up 4. So let's look at this. So y is 1 over. So in this case, if it's shifted to the right 2 units, then I don't just have x in the denominator. I have x minus 2, right? Because it went to the right. So x minus 2. That's what indicates to the right 2 units, correct? So there is my horizontal shift. Now I want my vertical shift. My vertical shift is up 4 units. So I just add 4 outside of this. Is everyone okay with how I wrote the new function at least? Okay. So that's the new function. How do we graph this thing? So this one's a little harder to graph. So let's do this. So here, whenever you have a standard y equals 1 over x, look here, the point of, I just say reflection is 0, 0. Now it's going to be the point 2, 4 because we shifted it over 2 to the right and up 4. So let's say over 2, up 4. 1, 2, 3, 4. So let's say here, so obviously this is not going to be a great graph. So 2, 1, 2, 3, 4. So here it's going to look something like this. Here it is on the bottom piece. Here it is on the top. It looks something like that. But that is the new function when you shift it. It looks like that. So the orange graph is the shifted graph. Shifted graph in orange. So is everyone okay with that second example there? So now let's go on to this third one here. So it says in the given graph, the temperature T in degrees Fahrenheit of a home is given as a function of the time T in hours after midnight over a 24-hour period. So the first part says at what temperature is this thermostat set during daytime hours? So during daytime hours, it's looking at in between, looks like 7 a.m. and what is that? 7 p.m. So in this case, between 7 a.m. and 7 p.m. What do you think? Looking at the graph there, what is it? Not 70, it's close to 70. Anyone else have any other guesses? 71 is correct. So, what is the temperature of the thermostat during the daytime hours? 71 degrees Fahrenheit. What about during overnight hours? What's the temperature? .58 is correct, yeah. 58 degrees Fahrenheit. So those two are just reading the where the horizontal lines are at. So now it's talking about what happens when we shift this thing. What does it look like? So it says the homeowner reprograms the thermostat to Y is T of T minus 5. Explain how this affects the temperature in the house. So in this case, it just shifted the graph down 5 units, right? So it shifts the graph down 5 units. This shifts the graph down 5 units. So the new daytime temperature would be what? Yeah, 66 is correct. Yeah, all we're doing is just taking that 71 degrees, shifting it down 5. So it would be 66 degrees Fahrenheit. And the new time temperature would be what? 53, yeah. They call it overnight. Let's just say the new overnight. Would be 53. So that was the vertical shift, right? Up and down. Now, this is a horizontal shift, left and right. So it says the homeowner reprograms the thermostat to Y as T, evaluated at T plus 3. Explain how this change affects the temperature in the house. So in this case, it's a horizontal shift, and it's to the left or the right. Yeah, it's to the left 3 units, right? So it's a horizontal shift, left 3 units. So then the temperature inside the house So in this case, it wouldn't be measured after hours after midnight. It would be measured by number of hours after what time? Number of hours after what? Anyone have any idea? What's 3 hours before midnight? Yeah, 9 p.m., right. So since we shifted it left 3 hours, that means we're just 3 hours before midnight, which is 9 p.m. So is everyone okay with that one there? These are all just different examples of shifts. We're talking vertical or horizontal. So the last thing we'll go over for today is this class activity here. So this is a standard y equals x squared, but this is the shifted version of it. So let's look at this first. So is there a horizontal shift? If there is, indicate the direction. So someone tell me, if there is a horizontal shift, what direction and how many units? So is it left 3 or is it right 3? What do you think? Right. Oh, right. Because here, so this is right 3 units. What about the vertical shift? What is the vertical shift? Up or down and how many units? Up 1 is correct. Yes. Up 1 unit. Now, is this graph reflected or no? No, it's not. It's not flipped. So then the new equation for this one is as follows. So first we have our shift right 3 units. This would be indicated by x minus 3 right here, right? Instead of plugging in x, we plug in x minus 3. And remember, it's squared. And then 1 unit, we add 1. That's the new equation of the function. Are there any equations over or any questions over any of that there, over those 2 sections of notes? Okay. So some of you sent me an email in regards to those mini exams that I said you could do in place of the first exam if you didn't do as well as you would like. So I forgot to take off the lockdown browser on those, and it gave some of you some trouble. So what I did is I went ahead, I went through, I edited the settings of those mini exams for the first module where there is no lockdown browser. You still only have 45 minutes to complete each of them, but they're not due till Thursday night. So if you still want to do those, if you didn't do as well on the exam as you would like, and you want to do better and improve your score, you can retake the exam by doing those mini exams, mini exam 1A, 1B, and 1C, and I will take the average of those 3 exam scores. And that will be your exam 1 score instead of the one you have right now. But that is due on Thursday night by 11:59 p.m. I don't know if we're going to have class in person on Thursday or not, but if we are, I will see you then. If not, we'll probably be back here on Zoom. I did record today's class, so if you do forget anything, I will post the recorded lecture on Moodle here shortly. How I did it last time is I just posted it on YouTube, and then I posted the YouTube link, and you can click on it, and it will take you right to the video. If no one has anything further, I will let y'all go, and I will see you all on Thursday.